Okay, so anyway, I can start for a while anyway. Within Intel, we think that storage and memory is one of our key areas for growth because we understand that PC market is declining, so we are trying to focus more and more on data center, IoT usage models, and to enable those areas, we really need to be focusing on memory as well. Here in the event, you saw our SSDs. Some customers are showing our SSDs, and you saw Intel FPGA and others. Okay, so like I said, memory is our focus area for growth in the next few years at Intel. And right now we have two key technologies for our SSD and going forward memory products. We have Intel 3D NAND, and we have Intel Optane technology, which is based on 3D crosspoint, as you probably know. So the idea here on this particular slide is to understand that 3D NAND and Optane, they don't really compete with each other. They cover different usage models and different market segments. With 3D NAND SSDs, we are targeting more towards hard drive market because we don't see reason to use hard drives in many usage models right now. Even though hard drives are still cheaper than NAND-based SSDs, the total cost of ownership is getting closer, and performance per dollar is much higher with SSDs right now. With Optane, we are targeting the highest ends of SSD market right now and also DRAM market, because we think with value proposition of Optane, we can really take part of some of the DRAM usage models. And I will show you some benchmarks which we did, which will show you Optane performance numbers. Speaking of NAND and flash technologies overall, Intel has a long story with flash technologies. We started with NOR technologies in the 80s. We moved to NAND in 2010. We had a couple generations or few generations of planar 2D NAND before. And important thing happened last year. We switched all our lineups to 3D NAND. And that's the general trend in the market. Every SSD vendor is moving to 3D NAND just because it is more cost efficient, enables higher densities, and keeping the same level or even better levels of performance. So why do they think that Intel 3D NAND is better than others? First of all, with Intel, we are using so-called floating gate technology versus so-called charge trap technology, which many of our competitors are using in SSDs right now in NAND. We believe that floating gate enables better density of the solution, and partly because of that, we can get more gigabytes from one wafer of NAND. Another thing which enables us to have better density is the periphery under the array. So all our CMOS infrastructure is under the array versus other vendors who have CMOS around the array. So we think that our overall areal density is about 11% higher versus competition. But it's not only about the density, which essentially enables us to produce NAND with lower costs. We think that floating gate is more reliable in terms of leakage. So electrons are not leaking that fast from floating gate cells compared to charge trap. So that's why we think that floating gate is more reliable as well. Not only cheaper and more scalable or denser, but also more reliable. Speaking of products, so you can see that starting mid of 2016, we started to launch all the products based on Intel 3D NAND only. No other NAND technologies we're using, no third-party NAND, no 2D NAND anymore. Everything is on 3D NAND right now. And going forward, we'll be refreshing our 3D NAND with next generations, increasing number of layers in the 3D NAND, increasing solution densities, and the prices will eventually go down after we go out of this fancy situation on the market right now with high NAND prices, you know. So eventually prices will go down. You can see that right now with 3D NAND, we have products in all segments. We have consumer products, we have embedded products, and we have data center products, both in the SATA space and in the NVMe space. Today, I'd like to focus more on our 3D NAND-based NVMe product, P3520, which, like James presented, DDN is using in IME appliances right now. So it is our standard endurance NVMe product based on first generation of Intel 3D NAND. First of all, it is very reliable. We had internal case studies about overall quality, silent data corruption protection, parallel protection, etc. We believe that this is one of the highest quality and most reliable products on the market right now within SSD space. Performance-wise, obviously, being NVMe device, it is much faster comparing to SATA and SAS SSDs, and 10 times, 100 times faster than hard drives for random operations, obviously. Another thing is IOPS consistency, because for many usage models, you don't only need the high performance, but you need the performance which will be consistently high. With PE3520, we are getting high performance, and the consistency is quite good. That's why James was able to show very good performance numbers out of AME boxes, because of the high performance and high consistency. Important thing happened, and sorry for the phones, but important thing happened back in May, so last month. Intel introduced a new generation of NAND-based NVMe products, P4500 and 4600. The key thing which changed is the new controller, and in data center drives, Intel is using Intel-developed SSD controllers. So we launched our new generation of controller, and we changed a lot of firmware code for that. So overall, now we can have solutions of higher capacity, and actually now SSDs in capacities go higher than hard drives in the market, and also the performance is much better comparing to our previous generations of products. So you should expect to see those products in the market, I think, in July already. And they will be available to purchase for our DCs, and we'll definitely work with DDN to have them qualified and included in the next generations of AME products. And let me, something with phones again. Let me briefly touch 3D XPoint now. So the idea to develop and introduce 3D XPoint was because we see the gap between DRAM and NAND in the market. DRAM is very fast, very expensive, and have rather low capacities. With NAND, capacities are quite high these days. The price is relatively low, but the performance is much lower comparing to DRAM. So there is a gap in the market. What 3D XPoint introduces is the latency, which is quite close to the DRAM latencies on the media level, not on the solution level yet. And size of data or density is quite close to NAND-based devices. So essentially it means that in the memory space, you can have devices which will be fast enough for many usage models, but which will have much higher capacities comparing to DRAM, much better densities, and lower cost per gigabyte. In the storage space, you can expect SSDs, which will be much faster than current SSDs, much lower access latencies, while about the same capacity levels. So that's why we think that it enables new... I didn't know we have animation here. So that's why we have new usage models for that. So I'm going to show you a few test results which we did with our recently launched Intel Optane SSD DC P4800X product. We announced that back in March. It is available from our certain partners right now. So first of all, one of the value propositions of Optane is the good performance. And by the way, Optane is Intel brand name for 3D XPoint based SSDs right now. So one of the value propositions of Optane is the high performance with low Q depths. As you probably know, with NAND-based SSDs, performance increases with overall Q depth. So if you use many queues and deep queues, the performance will be better. But we saw that the majority of workloads in the data center, they're not fully utilizing the NAND-based SSD performance, just because they're using less queues with rather small depths. So if you compare performance of our fastest NAND-based NVMe SSD to date with Optane SSD, you'll see that on the Q depth of 1, the performance is 8 times difference. If you increase Q depth up to 16, the performance will be 5 times difference. And if you keep increasing with very high Q depths, the performance difference will be 3-4 times depending on the workload. And also you can see that Optane device maximizes performance at Q depth of 12. So if your workload using small Q depths, Optane will be much faster for you compared to any existing NAND-based device. Another thing is about latency and quality of service of latencies. Again, in blue we have our NAND-based device. In orange we have Optane. First of all, and by the way, this is the mixed read-write workload, and we are measuring latency for reads. First of all, you can see that average latency of NAND-based device is quite good. It is worse than Optane, probably a few times worse than Optane, but it is quite good. But if you want stability of your IOPS, you see that with 2 nines of quality of service, the difference between Optane and NAND 60 times. If you increase number of nines to 4 nines, you'll expect like 77 times difference. With 6 nines and above, it will be 100 times and more. Just because Optane is very stable. It doesn't really care between reads and writes or mixed workloads. It can do all operations with equal latencies. Another slide shows responsiveness under loads. This particular test shows you that when you do the stream of writes, you're doing random writes on the SSD and measuring random read latency, which is almost the worst workload for the SSD. With NANDs, you can see that your latency will be increasing with write pressure increasing, and the deviation in latency is increasing greatly. With Optane, it is stable all the time. So you see that latency is stable and the deviation is stable. So essentially, like I said, there is no difference between reads and writes. It is very important for the workloads where you're writing the data all the time, but need to read data sometimes, like read metadata probably from the system or do any user data read operation. With Optane, you should expect many times difference versus NAND.
Alex?
Yeah.
Is this curve here for NAND due to garbage collection?
Yeah, that's mostly because of the garbage collection. Yeah. Yeah, with Optane devices, we don't have garbage collection per se, just because we can rewrite data within the egress point. We don't need to erase data. We don't need to do garbage collection just like we do in NAND-based devices. That's why it's stable all the time. That's the thing which enables great quality of service with Optane. And another thing I want to show you is this slide which touches future a bit. So right now we have NAND-based NVMe devices. On the left, you see latency levels about 90, 100 microseconds. When you switch to Optane SSD right now, you cut down latency to about 10 microsecond levels. And if you do NVMe or Fabrics or something, Fabrics will add maybe 10 more microseconds. So remotely attached Optane SSD will be faster comparing to directly attached NAND-based NVMe SSD. That's one thing to understand. In future, Intel plans to launch a DIMM form factor product based on 3D crosspoint. It won't be DRAM, it will be 3D crosspoint based Intel DIMM, which will obviously use the memory bus to address data, and the latency will be much lower. We are talking nanoseconds, well, few hundreds nanoseconds of excess latency with this product, which is still somewhat higher than DRAM, but much lower than any existing block device, obviously, and the price per gigabyte will be lower comparing to DRAM. So, which means that in future you should expect hybrid configurations where our partners may be mixing DRAM and Intel DIMMs, adding Optane SSDs for further memory extension or for the highest end of storage tier, like high performance tier and Lustre probably, or burst buffers, IME product maybe in the future. So this is the direction of which we see market is going right now. I think I have 1 minute for questions.
So, what do you give us a guess when you expect to see Optane in a kind of prominent position in the HPC market? Is that going to be a 2-year time frame or next year? Or
Optane SSD, you mean, or overall Optane? That's all Optane. So we have few partners who are investigating HPC usage models right now. We are running few proof of concepts with few partners right now. We expect that next year we will have something in production in HPC as well. Maybe end of this year already. But the mass adoption we expect will be next year. Yeah. Across different segments, not only HPC, but storage and others. Yeah. Thanks, James. All right, thank you.